Hello gang, in this video you're going to learn how to find limits if given the graph of a function, and these are called graphical solutions. Pretty obvious because we have a graph here, and the function that you see here, this covers pretty much anything that your prof or teacher will throw at you. So we're going to start on the left and work our way through this. Okay, so first off we'll find out what the limit is. The limit as x goes to -4 from the negative side. See this negative? So that here's -4 here of f of x, and this is our function f of x, this blue line here. And so as we approach -4 from the negative side, so that means it's from the left, imagine you're in a car and you're on this function's a road, and you're on a car traveling down the road. The limit as x goes to -4 is where you will be going. Where are you headed to? Where are you approaching as you go to -4? So as you go down this road in the car, as we go to -4 from the left, we are approaching the value of the function, which is right here. So it's about 1.2. It's about 1.2. So the limit as x goes to -4 from the left-hand side is about 1.2. Hey, now the limit as x goes to -4 from the right-hand side, from the positive side, same thing. You're a car on the road and you're approaching -4 from the right. So you're going towards -4. Where is the function going? We're also approaching the value of 1.2 as well. Now here, this is the limit. The limit as x goes to -4. There's no plus or minus here, so this just means like the overall limit. So what is the limit as x goes to -4? And as we approach -4 from the left, it's 1.2. As we approach it from the right, it's 1.2. Since we're approaching the same value from the left and the right-hand side, they're equal, then the overall limit as x goes to -4 is also equal to 1.2 as well. And this last one here, this always comes up on exams, f of -4. So what's the value of the function at -4? So when x is -4, what's the value of f? Well, you plug in -4 for x, then the function is 1.2 as well. Okay, so the next one, as we work our way over, what about to -3? Well, the limit as x goes to -3 from the left-hand side of the function is, where are we approaching? We're on the left-hand side, we're in a car, we're traveling down the road. The function is approaching here, 2. So it's approaching 2 from the left-hand side. Same thing from the right-hand side. As we approach -3, we're going in the car. The function is approaching 2 as well. Since these two match, the limit from the left-hand side is equal to the limit from the right-hand side. Then the overall limit, the limit as x goes to -3, is also equal to 2 as well. And what's the value of the function of -3? Well, if you plug in -3 for x, the function doesn't exist. See, there's a big hole here. So even though the limit exists, the limit tells us where the function is approaching. What value is it approaching? But it doesn't actually exist on that value itself. They're both headed to the value of 2, but if you plug in -3 for x, the function doesn't exist. So does not exist, DNE here. All right, next example, so we're going to go to 0. So as x approaches 0 from the left-hand side of the function here, so we're on the left-hand side approaching x equals 0. Where are we headed? Well, the road is taking us to 0. That's the value of y. So y is equal to the value of our function here. And the function is approaching 0 as x goes to 0 from the left. Now, what about from the right-hand side? Well, we're on the right-hand side of 0 here, and we're on a car, we're going down the road. The function is approaching 3 as x goes to 0. The value of the function is approaching 3. What about the overall limit? Well, as we approach 0 from the left, we're approaching 0. The value of the function is going to 0. But if we go to x, as x goes to 0 from the right-hand side, the function is going to 3. So these are not equal to. There's a discontinuity here. This is called a jump discontinuity. Since the left-hand side, the limit from the left doesn't equal the limit from the right, then the overall limit does not exist, DNE. There is no limit as x goes to 0, only if we specify which side. What's the value of the function when x equals 0? We'll plug in x equal to 0. It's not this one because this is an open hole, so it doesn't exist here. It exists right here. So when x equals 0, the value of the function is 3. All right. as x goes to 2 from the negative side. So here's x equals 2. We're going to approach it from the negative. So here we are. We're in a car. We're traveling down the road, and the function is headed to here. It's headed to a value of 1. That's the value of this point right here, and that's where the function is approaching from the left-hand side. So it's 1. What about from the right-hand side? Again, we're following it to that's approaching 1 as well, to that same point. So it's approaching 1. Since the limit from the left-hand side equals the limit from the right-hand side, the overall limit exists. So x goes to 2 is 1 as well. And what's the value of the function? X equals 2. So if you plug in x equal to 2, it doesn't exist here. It exists here. So this is a piecewise function. They call this a removable discontinuity. If you want to impress someone at a party, plug in x equal to 2. The value of the function exists right here at -1. So the function at x equals 2 equals to -1, but the limit is where the function is approaching. Okay, so next one here, we're going to 5. You're in a car, and we're going to find out the limit as x goes to 5 from the negative side, which is from the left-hand side, where we're in a car here traveling to 5 from the left. Where is the function approaching? Well, it's approaching this value up here, which is 3. Same thing from the right-hand side. As we go to the left from the right, from the positive side, we're approaching that same value, 3 as well. Since the limit from the left equals the limit from the right, the overall limit exists as x goes to 5. It's not 5, it's 3. And what's the value of the function at x equals 5? Well, we plug in x equals 5, and it exists right here. This is our closed circle, so the value of the function is 3 as well. This is, there's no defined slope at x equal to 5, but there is a defined limit as well. All right, next example here as x goes to 6. So as x approaches 6 from the left-hand side, the negative side, so we're here and we're approaching 6. X is going to 6. Well, look what happens to the function. The function starts tanking, starts going down, very, very negative. And this dotted line means it's an asymptote, which means that the function will approach but never touch or cross this line. So it's going to go all the way down to negative infinity, essentially. So that's where it's headed. Now, negative infinity isn't a value, so there's no defined limit per se, but it's going off to negative infinity from the left. Same thing from the right. X is going down, negative infinity. Now, since these both have the same limit, even though this isn't a number, we say that the limit as x goes to 6 is negative infinity as well. Now, if one of these were to go up to positive infinity, then the limit wouldn't exist because one would be negative infinity, the other one would be positive infinity. But since these two match, the limit is negative infinity. And what about the value of the function at x equals 6? Well, if you plug in x equal to 6, we're right on the asymptote. And by definition, a function will approach but never touch or cross an asymptote. So it doesn't exist. The value doesn't exist at that point. All right, last one here, we'll look at the end behavior as x goes to negative infinity. So here we are at -5. As x goes on to negative infinity, what's happening to the function? It looks like there's an asymptote here. Now, it might not be. It might just be straight. But it looks like it's right in line with this -1 here. So it's either approaching -1 or it's staying right on -1, assuming that there's no other changes with this function, of course. And then over here, as x goes to positive infinity, so we're here, as x gets larger, the function gets larger as well. And if there's no other changes to the function, then as x gets larger, this function is just going to get larger and larger and larger. So as x goes to positive infinity, the function will go to positive infinity as well. Okay, everyone, so that's it. We went through pretty much any example that you'll see on an exam. Did any of these examples come up on a midterm or a final exam for you? Let me know. I'd be pretty curious to find out. All right, thanks again, and I'll see you in the next one. Cheers.